Welcome to the ConfLang workgroup of Splash 2021. I am Marcel from Lohuizen. I recently left Google after almost 19 years of tenure. One of my claims to fame was being on the founding team of Borg, the inspiration for Kubernetes, where I led the development of BCL and GCL as well as the Borg orchestration tooling. Some of you, though, may know me better for my work on the Go team. At my time of Google, I've seen various approaches to configuration, none of which were really satisfying solutions. In general, configuration management is still believed to be an unsolved problem. In the full talk linked from the schedule, I present the lessons learned from configuration at Google and how these have culminated in the new language called CUE. I'll give a short overview here. The two most important initial requirements for GCL were based on experience with Google's pre-Borg production system, namely, don't do complex computation in configuration and don't use more than one layer of override. The basic idea here is that it should be easy to see where configuration values come from. But GCL ultimately did not meet these requirements. Firstly, why is this important? Basically, configurations are often changed in a hurry and also by teams that did not originally write the configuration. This makes readability and maintainability even more important for configuration languages than for programming languages. Yet, the properties of GCL and many of its descendants make it more akin to a scripting language. So the hypothesis is here, DSLs often fail not because the requirements are bad, but because they ultimately do not meet the requirements or address the actual needs for a configuration language. In the full talk, we identify various issues of GCL, but the biggest design failure, though, was the introduction of inheritance. Allowing override inheritance gave rise to the largest source of complexity in configuration. In other words, it made it hard to see where values were coming from. What we need instead, really, is composition. What that means more technically is that we want these properties, that composition is associative, commutative, and idempotent with no exceptions. And that's just really a fancy way of saying order doesn't matter. Unlike with inheritance, with these properties, configuration elements can be combined in any order and the result will be the same. It's this property that reduces complexity relative to using overrides. CUE is a complete rethink of how a DSL for configuration should look like, and it has the desired properties we just discussed. In the full talk, we give more detail and examples of CUE, but in short, it's composable, it's constraint-based, it's aspect-oriented, which fits closely to the cross-cutting nature of configuration. Its types, constraints, and values are all defined in a single partial order, a lattice to be precise, and it's designed to satisfy the requirements for a variety of roles. Key to CUE, though, is that it handles all aspects of configuration holistically in a single domain. You can think of CUE as a typed JSON spreadsheet where each cell in the tree can have values, derived values, and constraints. A very cool and well understood side effect of this approach, already observed in CUE's logic programming ancestors, is that constraints can be both generative, so can derive values, and can be used for validation simultaneously. This is really a profound feature that one needs to use to appreciate. CUE solves the complex computation dilemma. I refer to the full talk why we refer to this as a dilemma. Without going into too much detail, the basic idea here is that we can rely on CUE's computational model to create a strict separation between code and configuration. So jumping back to the spreadsheet analogy, this is comparable to how in spreadsheets code for functions is kept separate from the data and the formulas, but can be referred to within the spreadsheet for evaluation. CUE's composition also solves the abstraction dilemma. Again, without going into too much detail, for one, abstractions are no longer needed to guarantee safety as we have constraints for that. But for cases where abstractions are still desirable, one can once again rely on the compositional model to mix expanded abstractions with constraints and low-level direct definitions on the underlying API without any ambiguity. Other problems that CUE solves are catching typos in field names where retaining extendable API semantics is important, allowing for convenient fine-grained constraints, and allowing cycles to solve the field templating issue, to support recursive types, and solving some of the more obscure software engineering challenges found in GCL. So I'm looking forward to the discussions in the workgroup. I hope to see you there, but if you can make it, feel free to ping me on one of these channels. Thank you for your interest, and don't be afraid to ask questions.